Dear friends, this is my tutorial 33. In this tutorial I am going to explain how to do and plot ROA spectrum of alpha-fining using Gaussian and Multiwfn softwares. So this is the simulated ROA spectrum of alpha-fining. So ROA means Raman Optical Activity spectrum. So before going to do Raman's optical activity calculation, we have to optimize our alpha-fining first. So this is our alpha-fining ROA folder. So first we have to do optimization. So this is the alpha-fining, alpha-S-fining optimization folder. So I will show you the input files for geometry optimization using Gaussian. So just I will right click with Notepad++. So this is the input file. So here you can see %chk equal to spining.chk. So you have to mention your system name, whatever you want. You can give the keyword here. Then you have to give memory and npro shared. So I am using this is the Windows version. For that I mentioned 6MW npro shared 2. So if you are using Linux version, this may change according to the system configuration. So here theory I am used B3LYP. So this is the basis set I used for geometry optimization of alpha-S-fining. So here I mentioned that optimization and frequency keyword. So first the Gaussian will do the optimization. After completion of optimization, the second calculation will run that frequency. So this is the root section keyword of this input file. Then you have to give space. Then you have to mention the molecule name or system name, whatever you may prefer to give, you can give. Then you have to give space. Then you have to give the charge, total charges of the system. So alpha-fining total charge is 0. So here we have to give the spin multiplicity. The spin multiplicity is 1. These are the Cartesian coordinate of alpha-S-fining. Where to get this alpha-S-fining structure and how to get that Cartesian coordinate of this alpha-S-fining. So first go to Google. Just go to Google. Just to type alpha-S-fining pubchem. So you will get here two kind of thing. This is the R alpha-fining. This is S alpha-fining. This is the one. Okay. Just click it. So here you can see the name. So S-fining, S alpha-fining. Just to go down, you can see here a 3D conformer. So if you want this structure, just to go here, download coordinate. Just click this SDF. And it will download here. So if you want to see this structure with your Gauss view, just to go to Gauss view, open your Gauss view, just to drag this. So this is the alpha-S-fining structure. So if you want that Cartesian coordinate, just go to file and save. Here you can see MDL SDF file is there. Just you can change into GJF file format. Here you can change into the name alpha-S-fining. So you can make any folder on your computer. So I will make one folder into the C drive here itself. Alpha-S-fining and save it. So we will see that a Cartesian coordinate of alpha-S-fining. Yeah. So this is the one we have saved Cartesian coordinate of alpha-fining. So we have to use this Cartesian coordinate to optimize that alpha-S-fining structure. So this is that Cartesian coordinate. Already I copy pasted here. I did that geometry optimization also. So now we will view that optimized structures of alpha-S-fining. So we have to go to our folder. So this is that optimized output file. Just we can view this structure using Gauss view. So just to drag into that dot out file, you can see spine in dot out. So this is the optimized one. So if you want to see results, just to go to result, you can click summary, you will get the summary of the things, what theory used, what basis set used, what is the charge and the spin multiplicity, and what is the total energy of the system, dipole moment and polarizability, and everything you will see. So if you want, you can use these things. So now if you want to see that vibrational frequency also, you can see, go to file, click vibration, you can see that frequencies of this one. If you want to see the vibration, just click start animation, it will start. Just to click one by one, you can see different kind of vibration. So that's all. Now if you want to stop, you can click stop and close it. So now we have to use this optimized Cartesian for ROA calculation, Raman Optical Activity calculations. So we can use this optimized Cartesian coordinate to make the input file for that ROA calculations. So this is the ROA calculation folder. So I have already done that calculation. This is the input file. We can see that input file for ROA calculation here. So what we mentioned in that optimization, similarly we have to give here. So here you have to mention ROA. So then only we can understand easily which calculation this one. So then here I used 20 GB memory and ProShare 40 because I used the Linux system to do the ROA calculation. So then we have to give the root section keywords. So this is the root section key, this is the theory I used. So this is the basis set I used for ROA calculation. So we have to use that diffuse function basis set in order to do the ROA calculation. So keep in mind this. Then this is the keyword for ROA calculation. Here what you have to do, just you have to give freq equal to ROA. You have to give this keyword in order to get your ROA spectrum. Then you have to give space, then you have to give the name of the system, then you have to give space, then you have to give the total charge of the system, then spin multiplicity of the system. Then this is the optimized Cartesian coordinates. So you have to use from that optimized output file. So you should not take that without optimized structures. You should understand that. Then you have to give this kind of frequency. You can give 1 also fine. If you want to give, you can give 3. It's fine. So this is that Raman incident light wavelength. This is enough. If this is the 532 is that visible region Raman incident light wavelength. So basically many people will use this 532 nanometer. So likewise you can give 3 incident light nanometer that wavelength. That's enough. Then you can give space. Then you can save this file. Then you can submit this calculation into your Linux system or your Windows system. So the calculation will complete soon. No problem. So this is the optimized output file for that ROA calculation. Just we can see using Notepad++. So this is the output file. So here you can see we have mentioned that theory and basis set that ROA keyword. Okay, this is the important things. So then if you go down, you can see the normal termination of Gaussian 16 calculation. That means our calculation completes without any error. So now what we are going to do, we are going to use this output file in order to make that ROA spectra using that Multiwfn softwares. So I will tell you that, no problem. It's very simple only. So for that we have to open our Multiwfn software. So this is the folder of Multiwfn software I have downloaded from the website. So if you want to download, just go to Google, just you can type Multiwfn download, it will direct to that page. Then what you have to do, then you will see the different kind of versions, Mac version, Linux, Windows. Just to choose Windows version, then you can download it and you can extract that this folder. You can keep it in desktop, wherever you want you can keep. That's all. There is no installation of this Multiwfn, just you have to execute this is the software. So this is the Multiwfn software. Just we can double click, it will open. So now what we have to do, just to press enter, then only the one small window will open. This window to locate our calculation folder. So here you can keep path for that ROA calculation folder. This is the our folder. So this is the optimization, this is the ROA calculation folder. Then you have to highlight this optimized output file, ROA output file. Then click open. Now it will open that Multiwfn main function menu. So this is the main function menus. So now we are going to do our ROA analysis. First, what we have to do, we have to choose 11. 11 means that to plot IR, Raman, UV visible, ECD, VCD, ROA, NMR spectrum. Just you can type 11. Here what you have to do, here you can see IR, Raman. We have to specify that number, which spectra we want. Here you see different kind of thing is there. So here we want only the ROA. That means we have to type 6 and enter. So here you see, so there are different kind of frequencies is there. So which one we are going to use? So here is a 500, 532, the 600 is there. So we are going to use 532. This is the second one, second option. Type 2 and enter. Now it will ask the which types load which types of data. So we are always use this number 2 only. Number 2, ROA SCP 180, that is SCP backscattered ROA spectrum. Just you can type 2 and enter, and you will get this page. Now we have to do one more important things, that is scale factor of vibrational frequencies. This is the very important. You have to do that. If you are doing frequency related calculation, you have to do the scale factor things. So type 14 and enter. Here you can see note there are 72 frequencies in total. So we are going to use 72 frequencies. For that, just you have to enter, means it will select all frequencies and enter. So it will choose all frequencies. So we have to give the scale factor here. So this is the important things. So I will show you the scale factor details. So if you go to cccbdp.nist.gov, you will get this vibrational scaling factor. Otherwise you can also just type vibrational scaling factor NIST like that. You will get this page. You can get your scaling factor value. So here you can see we are using density functional only. This is the theory we are using. So which base set you are using, just you have to choose. So we are using here basis set is AUGCCPVDZ only we are using. So that's why we are going to use this scaling factor value, that means 0.970. So this is the basis set, this is theory. So if you are using 631 G star, just you have to use this one, B3LOP. This is the 631 G star, 96 we have to use. This is the 97. So likewise we have to choose. So I will type 0.97 and enter. Then one more things we have to do for this ROA spectrum, that is 19. So this is the convert Raman ROA activities into intensities. So for that, just you type 19 and enter. So it will ask input wave number of incident light. So if, for example, if you want to type 532, just put 532. So we are going to use 532 only. Just I will put 532. 532, you have to give NM, you have to type NM also. 532 NM. Just enter. Temperature we have to choose. So if you press enter, default it will take the room temperature. So we want only room temperature only. Just again you can press one more time enter. Then it will show like this. So then if you want to adjust that x and x axis, so you can select 3. You can adjust the things. Okay, So now we will see our spectra now. So here you can see 0 plot spectrum. So we will type 0 now and enter. We will see our ROA spectrum of alpha S-pinene. So this is the one. So if you want to save this image into your calculation folder, we can save it easily. For that, what you have to do, just we can close it. Then you can see number 1. Number 1 means save graphical file of the spectrum in current folder. So now type 1 and enter, file will save. So if you want XY is a data set line, you can also get it. So you can use this file to make a spectra using your install that origin software. So just we can type 2 and we will enter, we will get that data also. So this is our ROA folder. So this is the saved ROA spectrum of alpha pinene. So if you want, you can also use this for publication. So if you don't want, you can just construct that ROA spectra using this spectra curve data file. So you can use your origin and plot it. This is very easy only. Just you can drag into that origin, you can make it your own plot and you can publish it. So that's all. So this is the very simple only. So you can so thank you for watching my video. If you like my video, please like, subscribe, comment and share, and also please click the bell icon bar for future video update. Thank you so much. Thank you for watching. Enjoy.